Alright, got an interesting demonstration here today. Ooh, that focus just killed itself. Alright, so I'm going to be showing a little ripple control system. Like a full ripple control system now. So, first off, before anything, in case I forget to mention it, check out Rodolfo 2007's videos on this. They're so much better. He works, I don't know if it works there, but he works on ripple control equipment, alright? And it's really neat in Auckland, New Zealand. It's actual equipment, but we don't have that here, so I was like, let's make it. So, I made my own ripple control system. Now, ripple control is used to switch hot water, street lighting, loads and stuff for off-peak and stuff. And how it works is it superimposes a high-frequency signal onto the mains power. Like, in Auckland's case, it's 1050 hertz on 50 hertz mains power. Here we have 115 volt 60 hertz, and I'm sending the 24th harmonic. I forgot what the frequency is, but it's the 24th harmonic, so if you want to figure it out, I'll probably leave it in the description. Anyway, let's go over the whole system. So, as you can tell here, here's my motor generator set. See? It's quite small, obviously, because I'm not transmitting into the actual mains. I have to transmit into an isolation transformer, because it would take a very large motor generator set to go into the mains. So, here's our motor. Here's a little generator. Right? It's actually a stepper motor, but it puts out a sine wave somehow. And it works. And it just happened to match the right frequency, so it's like, you know what, that's fine. So, up here I've got my custom controller that I built. Unit time, 2:45. That is correct. I don't know why I'm up at 2:45 making a ripple control video, but I am. Now, here's just a contactor that's used to switch the main power. It goes through this isolation transformer and all sorts of stuff over here that's going to be used to step the voltage up to 240 volts and stuff, because I'm going to be getting some actual ripple control receivers really soon. So, well, not necessarily really soon, but relatively soon. I will certainly make a better video on this then, but I thought, you know what, might as well make it now, because I've got it all set up. So people have showed their receivers before, like Tony88 did a very great demonstration on different receivers, and Rodolfo 2007 shows a lot of transmitter stuff, and there was one more person that showed the effect of cutting the power and back on ripple control receiver, but I'm going to show the whole system here. So, here's my controller, which I'll explain in a second, but first off, from that and all that stuff, which is just isolation so that it's safer, isolation transformer allows it so you can actually touch either side of it and you won't feel it. Or at least you'll feel it a lot less, if anything, because you're not going to get, like, immediately zapped. But that's why I have it running through that, so that it's safe. But then we go into this transformer. I would open it, but it's a pain. But, and we use this capacitor in this transformer, and that's connected to the motor generator set to transmit it. So effectively, how it works, mine's a little bit different, because obviously I don't have all the equipment that's perfect, so, because I can't really get a hold of it. But, effectively, it's parallel coupling, so you go through your motor generator set, through a transformer usually, and then right into the mains power, or probably 22 kilovolt or 33 kilovolt substation levels. But it would go through a capacitor on one side and straight in on the other side, and it's switched with a contactor. Of course, there's tuning coils and all that stuff, but to make it more stable. But yeah, that's basically how it works. So anyway, out of the transformer, we got this little thing. That's a nightlight that I've taped the photocell on. And out of there, we come down to what you've probably already seen before. This little power strip and my receiver I built. Yep, built a ripple control receiver. It's not ideal, and that's not too big of a problem, because I'm going to be getting actual receivers soon from a very nice power cooperative that's actually helping me out with this. I won't name them because I don't want you to go and bother them, but yeah. So if this doesn't end up working, if this misses a signal or something, that's because I made it, okay? Real receivers don't do that, because they use an LC filter instead of an RC filter, and they're a lot reliable. Anyway, that receiver is going to be switching power to this Christmas lights, so we'll be able to actually see it. So let's energize the whole system. And the purpose of the nightlight is so you can actually see the ripple signal flickering. Because you can see that. It doesn't come on like Christmas lights for some reason. I don't know why. They're LED and all, and I don't know, my signal just, it doesn't flicker on there. And this is actually a little bit too high of a signal strength, so, like, you really see it in this nightlight. That's, like, kind of my method of seeing if my signal is there or not, see if the nightlight flickers or not. But it does not show up in the Christmas lights at all, which baffles me. I don't know why. Usually it does. Anyway, motor generator set and all that. My transmitter here, I need to replace one of the relays in it because one of those relays isn't working. It's latched in the closed position. It's weird. The contacts are latched in the closed position, but it still clicks, so I have no idea. But something broke on that relay, and that, of course, is the relay that controls the motor generator set, so I'm going to actually have to use this little switch and turn it on manually. Other than that, this works 100%. So, on the controller, we're going to put it in halt mode. Now, Rodalco, if you actually end up watching this at any point, you will recognize that this is kind of based on that decabit controller you've shown before. So he actually showed a decabit controller before, and I thought it was really cool. It was old, so I vacuum fluorescent, key switch, old incandescent buttons, thumb wheel switches. I made it all old theme. Anyway, so now we gotta enter option 99. And actually, we gotta put in program mode. So then we can push right on option 99, gets us into engineer mode. How this works is it's meant for K22 and decabit, so that's what systems that Rodalco shows are. It starts with very long pulses. That's for old electromechanical receivers. That's why it's long, is because it needed a lot of tolerance in timing errors. But then it pulses decabit patterns for the newer solid-state receivers. So, yeah, I got the whole decabit protocol done, and my receiver gets it. So I guess I'll show this now. So, on startup, you see that little status LED there? That flashes like once every 2 seconds on startup before it receives the first signal. Otherwise, it flashes once a second. And here's a little bistable relay. I actually had to use relays to control the bistable relay, so that's fun. But it works, and this thing barely uses any power at all when it's on, because it's just a microcontroller and stuff, and it's very low power. In fact, like literally, the 7805 that I'm using doesn't even get warm at all. It used to, but then I fixed it, because like the resistor was pulling a lot of current. But yeah, that thing uses like no power at all. And in fact, it'll survive a really long power interruption because I put capacitors on there that actually let it do that. It's a buffer capacitor. Anyway, off topic. Let's get to transmitting it. So, we need to enable that too. So, what's going to happen is first I'll turn it on and I'll show it. I'll show the transmitter screen so you can see the decabit thing, and I'll show the nightlight flickering. And so we're going to transmit channel 0, and push that to transmit it plus. We got to turn the motor generator set on. I apologize, this is actually kind of an annoying sound it makes, but here we go. It was a lot worse when it was on the table, but yeah. So that's on. And now if we send the signal here, starting motor, it would be starting the motor generator set, but now we're sending. See how that's flickering? Well, it's not coming up as flickering, but it is flickering. It comes up as getting brighter, that's weird. But now we can see these Christmas lights have turned on, and the receiver has operated. So now let's use the master channel now, so channel 100 instead of 0. And there's 120, well there's 118, there's channels 100 through 118 are master channels, and 0 through 99 are individual channels. I'll explain this better later on. I'm trying to keep it a little bit short. Trying. It's like already 9 minutes, but let's turn it off now, and I'll show you the receiver. So watch the LED. See how it flashes faster? And it turned off. Now these are off. So now let's show the whole process. No, we can't. So let's use 100 and turn it on. So now we'll see the Christmas lights come on. You could probably hear the signal. There we go. So I was going to control one of these because they're used as street lighting all over the place. Mercury vapor lights, but the thing draws like 3.5 amps from the power. And my little transformer overheats, and it can't even supply that much current. The voltage drop is ridiculous. Yeah. I've actually got 2 of those. I need to do a video on them, but I haven't yet. But yeah. Eventually I'll set it up on a pole and control it with this. But now let's turn it off. And I'll show you the light turning off. Actually, you'll see the night light as well. There. So, yeah. That's my ripple control system. It's pretty neat. And if you have any questions about it, go ahead and shoot me a message in the comments. Of course, this is going to be a less thorough demonstration. I'm going to do a full demonstration when I get those real receivers. I'm actually impressed with how the performance of this went. This is actually quite reliable. Oh, and notice how it's flashing at once a second now? That's because it has received signals. And it does support failsafe modes, so I can have it... I can also send it a time synchronization command. Let's do that. I think I set it as 100... Oh. What was it? 120 plus. Right? Yeah, 120 plus. So watch down here. See, these are on the serial port. You'll see it log a lot of data. See? Wait, that wasn't it. That was the wrong channel. Let's try 100 and... I swear it was 120. It's gotta be. Let's try 120 minus, maybe. See how it's flashing faster when it's receiving? I don't know. I forgot what the thing is, but anyway. It works. And it has... Oh, I actually disabled that. That's why it's not working. But this receiver has support to keep time via the mains. That's why there's the big Ademco transformer. It's because this actually puts out a synchronization square wave signal. Obviously, I didn't have enough space to put a Schmidt trigger and all that on there, but it keeps time with the mains frequency, and if it doesn't receive ripple signals within a certain amount of time you set with the software, then it can switch to a time program. So, that's kind of interesting. I should do a video on that receiver someday, and how you program it. Oh, yeah, sorry for the long video. But, yeah, that's my ripple control system. If you have any questions, comments, I don't know, anything that I totally messed up on and you want to see me redo, let me know. And that's all.